January 2019 paper, Unit 6. The first is inorganic analysis. The inorganic compound A and B each contain one cation and one anion. A is a green solid. So what this give an idea, whenever there's a green solid, it might be iron 2, it might be nickel plus 2, or it might be chromium plus 3. So few drops of aqueous sodium hydroxide were added. It formed green precipitate, but the precipitate dissolved. So which case we have a green precipitate and the precipitate dissolved, that is in a case of a chromium. Like if it was iron 2, that will form with sodium hydroxide, it will form with sodium hydroxide, it will form green precipitate and which won't does not dissolve. So formula of the cation in A, that means it is chromium 3. Then dilute nitric acid followed by silver nitrate. So there's a chloride ion. What will be the observation? This will give a white PPT. Give a formula of an anion responsible for a green color for the final. So like why the solution dissolve, like why the precipitate dissolve? First, it will be a complex of a chromium 3 that was responsible for making a green solution. When we add sodium hydroxide, it will form chromium 3 hydroxide due to acid-base reaction, and there will be a green precipitate. When we add an axis, more like chromium 3 hydroxide is amphoteric, so it will react further or react more. So as a result, one more proton or two more protons will be lost, and it will form like chromium, then hydroxide like 4, and then H2O2. Now, because chromium is plus 3 and this minus 4, so there will be a charge of minus 1. So if there is a charge of minus 1, that's why the green precipitate dissolved to make a green solution. Dilute nitric acid and a silver nitrate, we did that. So the answer here for the solution, formation of a solution, chromium hydroxide 4 or 5, you can write any, and then 2 water molecules to balance the oxidation number, and the overall, because minus 4 plus 3, so minus 1 will be there. Ionic equation for test 2. Test 2, it's a formation of a silver chloride, so it will be Ag plus, which is aqueous, chloride ion aqueous, and form AgCl, that is solid. In part B, B is a white solid. 2 tests were carried out on a separate portion of aqueous solution of a B. Complete the table. Few drops of aqueous sodium hydroxide was added to sample B. If it is the formula of the cation, zinc is there. So when we add sodium hydroxide, first it will give a white precipitate. Sodium and aluminum both it give a white precipitate. But when we add an excess, the precipitate dissolved to form a colorless solution. So with zinc, it will be white PPT. And then the PPT dissolve. And it will form colorless solution. Dilute hydrochloric acid and aqueous barium chloride. So this is a test for sulfate ion. A white precipitate is formed. So when we have white precipitate form, it will be sulfate, SO4. Write ionic equation for test 3. So it's barium ion, which are aqueous, sulfate ion, which are also aqueous. It will form barium sulfate, which will be solid. Write ionic equation for 2 reaction in test 3. Oh, sorry, that's test 4. Test 3, we have to write ionic equation for 2 reactions. So I thought which was test 4. So test 3, like first we were having a zinc complex, so ZnH2O in a bracket 6. Then we add sodium hydroxide, NaOH is added. This will be positive ion, so it will form zinc hydroxide. Like two of the water molecule lose protons, so it become hydroxide. Zinc hydroxide plus 4 water molecules are there. This does not have any charge, and there are two protons which are being lost from the water. So this will be solid, this will be aqueous, this will be aqueous, this will be aqueous. State symbol is not required, but that is the first reaction. Now in the second reaction, what will happen? This white precipitate further this white precipitate further added uh, because like zinc hydroxides are also amphoteric, same like chromium hydroxide. So this white precipitate was there, and we add more hydroxide, like example 2, 3, any hydroxide you can mention, say more hydroxide. So further, two protons will be lost from the water, so it will form Zn, OH in a bracket 4, and then H2O will be 2, and the charge on the complex will be -2, and there will be two more protons lost. And these protons will combine with, because like H and OH will combine, so it will produce, if you write here, you can also write H2O, because two protons are lost which combine with this OH, so this will also be H2O. So that is due to formation of a white precipitate. This is due to formation of due to an ion, the complex ion, the solution, the precipitate will dissolve. In question 2, an ester C was hydrolyzed using a sodium hydroxide. The resulting mixture was distilled to give an organic liquid. The residue was acidified and a mixture was produced. Mixture purified to produce an organic liquid E. Uh, Spatula major of a phosphorus 5 chloride were added, separate D and E. Both give off a gas which produce steamy fumes in air and turn damp litmus. Identify by name or formula the gas produced uh, and the group present in D. So gas which is produced, that will always be with PCl5, it will be hydrogen chloride gas. And the formula of the group might be present OH. Because this is a PCl5 is a test for hydroxy group. Then D was oxidized to produce a carbonyl. State what function, additional information this give about. So like alcohol, primary alcohol can be oxidized. It produce a, like if it was a primary alcohol, it will oxidize to aldehyde and then ketone. Sorry, aldehyde and then carboxylic. If it was a secondary, then it will be oxidized to ketone. Carbonyl groups can only be produced by primary. So it give an idea that D might be primary or secondary. It cannot be tertiary. Because if it was tertiary, then it cannot be oxidized. Primary and secondary can be oxidized. The molecular ion peak. The molecular ion peak is 60 for D. The low resolution NMR consists of three peaks, relative area 611. Draw the structural or a displayed formula of D. So first, when we hydrolyze D, firstly, when we hydrolyze C, the ester, as a result, it will produce what? It will produce alcohol and carboxylic acid. And alcohol can be oxidized. So means this D should be an alcohol. This organic liquid D should be an alcohol. And we have to draw an alcohol with a molecular formula of 60. So which alcohol is having a molecular formula of 60? So using this, we identify number of the carbon atom. How to identify number of the carbon atom? With the general formula of alcohol is CN H2N. Like the general formula is CN H2N plus 1 OH, and the total mass should be 60 according to question. So using this, we work out what should be the value of N. like how many carbon should be there. This will be 12n plus this will be 2n plus 1 plus 16 plus 1 is equals to 60. When we simplify, 14n is plus 18 is equals to 60. This will move other side. So 14n is equals to 42, or n is equals to 42 divided by 14. So n is equals to 3. So means the number of the carbon in D should be 3. So we have 3 carbon atoms and the functional group OH is there. So we need 3 hydrogen environment. And we already identified either it can be primary or secondary, it cannot be tertiary. So if we use this, if it was a primary, like example, so CH2, CH2 and CH3. If it was a primary alcohol, then there will be 3 hydrogen environments like A, B, C, and the relative area will be 2, 2, and 3. So it can, but the relative area is 6, 1, 1. So it means it can, like 2, 2, 3 is the simplest ratio. So it cannot be primary. Now, if we draw 3 carbon atoms in a secondary, so OH will be here. Like there will be 4 hydrogen environment in the previous one, not 3, because if I draw the primary one, I did not count OH, this hydrogen. So there will be 4 hydrogen environment. But we need 3 hydrogen environments, so it cannot be primary, this means. So if it was secondary, this will be CH3, this will be CH, this will be CH3, and OH. So how many hydrogen environments are there? This is A, like identical environment. This is B, and this one will be C. So 3 hydrogen environments are there in relative area. Like if these two are A, which is having total 3 plus 3, 6, B will have 1 and C will also have 1. So it's 6, 1, 1. So this gives an idea that it should be a secondary alcohol, not a primary. Because if it was a primary alcohol, then there will be 4 peaks. But secondary alcohol, it will have only 3 peaks. Is it clear, this part? Then the next, aqueous sodium hydrogen carbonate was added to a portion of E. There was an immediate effervescence. So E should be a carboxylic, because when we do hydrolysis of an ester, it will produce carboxylic acid and alcohol. So the alcohol will be, as I mentioned here, when we hydrolyze, after resultant mixture was diluted, the resultant mixture was distilled to give organic D, and residue like remaining were acidified, and the mixture was purified to produce organic liquid. E should be a carboxylic acid. So name a gas given off when we add sodium hydrogen carbonate and fizz. So that will be a carbon dioxide. Functional group is carboxylic acid. In a mass spectrum, it also gave a peak at 60. So the general formula for carboxylic acid is CN H2N plus 1 COOH. That's a general. So this total should be 60. So this will be 12N plus this will be 2N plus 1 plus 12 plus 16 times 2 plus 1 is equals to 60. So this will be 14N plus this will be 28, sorry, 32. Like this is 12 plus 32 plus 1 is equals to 60, the total. So this one is also there. So the 32 plus 12, 44 plus 2, 46. So 14n is equals to, this will move other side, so this will be 14n is equals to 1, because it will be 14 divided by 14. So n is equals to 1 means it will be ethanoic acid. So if n is equals to 1, CH3COH, this is making an ethanoic acid. 12 into 224 plus 32 plus 4. So ethanoic acid we have to draw CH3COH. Then draw the displaced formula of ester. Look, one was ethanoic acid, one was ethanoic acid CH3 COH, and the other was alcohol was there. So CH3, CH3. Now what will happen? The carboxylic acid, like the whole carbon chain, like this H will be removed and this OH will be removed. And this whole carbon chain will be attached here. So the displayed or the structure formula, it will be CH3, COO is there. Then this C will be attached. This CH is there and then CH3 up and CH3 down. This is the ester which is formed by reaction between ethanoic acid and 2-hydropropane-2-ol. So this was Jan 2019.